Yes, absolutely. EMF meters, also known as EMF testers or EMF detectors, are quite common on the market. They measure electromagnetic fields and can detect both low frequency fields like those from household appliances and higher frequency fields like those from Wi-Fi routers or cell phones. There are various models available ranging from basic handheld devices to or advanced ones that can measure multiple frequencies and provide detailed readings. They're commonly used in research and home inspections or by individuals who are concerned about EMF exposure. On average, EMF meters can range quite a bit in price depending on their features and accuracy. Basic handheld models might start around $30 to $50, and these are usually did for general home use or basic measurements. More advanced models with multiple frequency ranges, higher accuracy, and more detailed data logging can range from around $100 to $300 or even more for professional grade devices. So there's a wide spectrum, and you can find something that it's who needs a budget. EMF meters are primarily designed to measure electromagnetic fields, so they're really focused on detecting and measuring EMF radiation rather than the physical properties of conductors themselves. If you're looking to measure something like surface resistivity or the conductivity of a material, you typically need specialized instruments like a multimeter, an ohm meter, or specific conductivity tester. EMF meters won't give you that direct measurement of the conductor's surface properties. Sure, to measure the conductivity or surface resistivity of materials, you typically use tools like multimeters. These can measure resistance, voltage, and current, and some advanced models also measure resistance to determine conductivity. Ohm meters, these are more specialized for measuring electrical resistance, which can be used to infer conductivity of a material. Conductivity meters, these are specifically designed to measure the electrical conductivity of liquids or solids, and they're often used in scientific and industrial applications. You can find these products at electronic stores, online marketplaces like Amazon, or specialized suppliers that deal with scientific equipment. Let me know if you need more specific recommendations. Absolutely. The main difference is that resistance refers to how much a material opposes the flow of electric current overall. It's a general property of the material and depends on its length, cross-sectional area, and the material's intrinsic properties. On the other hand, surface resistivity specifically measures how much resistance there is to the flow of electricity across the surface of a material. It's often used for thin films, coatings, or materials where the surface properties are more important than the bulk properties. So, in short, resistance is a more general measurement of how a material opposes current, while surface resistivity focuses specifically on the resistance law on the surface. Let me know if you need any more details. For testing grounding sheets or grounding pillowcases, you can use a specialized device known as a grounding tester or a multimeter with certain capabilities. Grounding testers are specifically designed to measure the continuity of the grounding system and ensure that the connection to the earth is solid. A basic multimeter can also help. You can measure the resistance between the grounding sheet and a known ground point, like a grounded outlet or a grounding rod. When you do this, you're essentially checking that the resistance is low, indicating a good connection. So there are also specific grounding testers available online that are made just for checking the effectiveness of grounding systems in general. And they can give you a good reading on whether your grounding sheets are properly connected. You can find these devices at electronic stores, online marketplaces like Amazon, or even specialty stores that focus on grounding and health related products. Let me know if you need more detailed recommendations. Absolutely. For grounding testers or devices that help you check the effectiveness of grounding sheets here, a few options. One, basic multimeters. Brands like Fluke, Klein Tools, or X-Tech offer reliable multimeters that can measure resistance. You can use them to check the continuity between your grounding sheet and a known ground point. These usually range from about $30 to $100 depending on the features. Two dedicated grounding testers, devices like the Ideal Industries grounding tester or the XTEC 30193 are specifically designed to test grounding systems. These can range from around $50 to $150, depending on the complexity and accuracy. Three grounding and earthing kits. Some companies that sell grounding products like earthing sheets or grounding mats also offer kits that include a tester. These are often designed to help you verify that the grounding is working properly and can range from about $40 to $100. You can find these products on platforms like Amazon, specialized electronic stores, or directly from companies that focus on grounding and earthing products. If you need specific recommendations or help finding a particular model, just let me know. Measuring resistance can definitely give you a good indication of whether your grounding connection is effective. If you measure low resistance between the grounding sheet and a known ground point, that generally means you have a solid grounding connection. However, it's important to keep in mind that resistance alone might not tell you the full story. For instance, it doesn't always reflect the quality of the connection under different conditions like variations in humidity or temperature. So while measuring resistance is a great start and often enough to confirm that your grounding is working, you might also want to consider checking the connection under different conditions or using a dedicated grounding tester for more detailed insights. But generally, resistance measurement is a solid and practical approach. Absolutely. When you measure resistance, it primarily gives you a snapshot of like the electrical continuity and the quality of the connection at that moment. However, it doesn't always account for how environmental factors like humidity or temperature can impact the grounding over time. For instance, high humidity can sometimes cause like corrosion or changes in the conductivity of the materials, which wouldn't necessarily be reflected in a single resistance measurement. Similarly, like temperature variations can affect the resistance, making it higher or lower depending on conditions. So while resistance measurement is a great indicator of the grounding quality at a given time, it doesn't always reflect like long-term stability or the impact of environmental changes. It's always good to consider these factors for a more comprehensive assessment. Yes. Yes, generally speaking, lower temperatures can increase the resistance of most materials. When it's colder, the atoms in the material vibrate less or can cause electrons to move more slowly and increase resistance. However, the effect can vary depending on the type of material. For metals like copper, aluminum, the resistance tends to increase as temperature drops. On the other hand, for some materials like semiconductors, the behavior can be more complex. But in general, colder temperatures do lead to higher resistance for many conductive materials. Exactly. Aluminum is not a semiconductor. It's actually a metal. Metals like aluminum have a large number of free electrons that can move easily, which makes them good conductors of electricity. In contrast, semiconductors like silicon or germanium have electrical conductivity that can be controlled by adding impurities or by changing conditions like temperature. This means semiconductors can act as both conductors and insulators depending on the circumstances, whereas metals like aluminum always have a high level of conductivity. That's why aluminum is classified as a metal and not a semiconductor. Silver is a metal. It's actually one of the best conductors of electricity, even better than copper and aluminum. Like other metals, silver has a large number of free electrons that facilitate easy electrical conductivity. So it definitely falls into the metal category rather than a semiconductor. When choosing a multimeter for measuring resistance and grounding, you can find a range of options. Budget-friendly digital multimeters like the Asher AI model typically cost around $10 to $20. Mid-range options such as the Gardner Bender model run about $20 to $30 for more advanced and precise measurements. Premium brands like Fluke start around $100 and can go much higher. For dedicated ground resistance testers, entry-level models like the Petrum clamp meter are around $22, while professional grade tools like the Fluke Earth ground clamp can cost about $2,700. Ultimately, the best choice depends on the level of precision and the complexity of the testing you need. I'm not able to send emails directly, but I'm happy to provide all the information here for you. If you'd like, you can copy and save the details, or let me know if there's anything specific you'd like me to elaborate on. No, a multimeter is actually quite versatile. In addition to measuring resistance, it can also measure voltage, current, both AC and DC, and sometimes even other parameters like capacitance, frequency, and temperature, depending on the model. So it's a handy tool for a variety of electrical measurements beyond just resistance. Voltage and resistance are related but distinct concepts. Voltage is the electrical potential difference between 2 points, essentially the force that pushes electric charges through a conductor. Resistance, on the other hand, is the property of a material that opposes the flow of electric current. They're connected through Ohm's law, which states that the voltage across a conductor is equal to the current flowing through it multiplied by the resistance, V equals I R. So while voltage and resistance are different, they're intrinsically linked in the behavior of electrical circuits. To check if your grounding sheets are working properly, you mainly want to focus on measuring resistance and continuity. Here's how each piece of information comes into play. Resistance, by measuring the resistance between the grounding sheet and a known ground point, you can confirm that the connection is solid. A low resistance reading indicates that the sheet is well grounded, meaning there's a good conductive path to the earth. Continuity, this test checks whether there's a continuous conductive path. If the multimeter shows continuity, it means the grounding sheet is properly connected and there are no breaks in the circuit. Voltage, while not typically the primary method for checking grounding effectiveness, measuring voltage can sometimes help identify if there's any potential difference or stray voltage that might indicate grounding issues. So in summary, focusing on resistance and continuity measurements would give you a solid indication of whether your grounding sheets are functioning correctly. You're very welcome. If you have any more questions or need further assistance, just let me know. I'm happy to help. I can't replay the conversation in the exact format, but I'm always here to help and recap anything you need. If you want a summary of what we discussed or any specific details, just let me know and I'll be happy to provide that for you. Continuity measurements are used to check whether there's a complete electrical path in a circuit or between 2 points. Essentially, it helps you verify that there are no breaks or open circuits. When you perform a continuity test, the multimeter usually emits a beep or a tone if there's a complete path, indicating good continuity. Continuity is typically measured in terms of resistance. If the resistance is very low, close to zero, that means there's good continuity. If the resistance is infinite or very high, that indicates an open circuit or a break. In short, continuity tests are handy for quickly checking wiring connections and ensuring that everything is properly connected. It really depends on the situation. In many cases, an open circuit can simply mean that a component or a wire isn't connected. It might cause like a device or system to not function properly. For example, if a grounding sheet has an open circuit, it may not be effectively grounding you, which could mean you're not getting the intended benefits. In other scenarios, an open circuit can be dangerous, especially if it involves high voltage or critical systems, because it can lead to malfunctions or even safety hazards. So the importance of an open circuit really depends on what the circuit is meant to do. It's always good to identify and address any open circuits to ensure everything functions safely as intended. Exactly, yes. Grounding sheets can indeed have an open circuit if there's a break in the conductive material or if the connection to the grounding source isn't solid. This could happen due to wear and tear, poor connections, or even a faulty grounding plug. Similarly, an electrical circuit in a room can have open circuits due to broken wires or disconnected components. The principle is the same in both cases. You want to ensure that there's a continuous, reliable path for the current or grounding to function properly. So it's definitely possible for grounding sheets to have open circuits, just like in the other electrical system. That's correct. The measurement device, like a multimeter, will basically detect whether there's continuity or resistance between two points, regardless of what those points are connected to. He won't inherently know whether the open circuit is within your grounding sheet or somewhere else in the room. It just measures the electrical path between the points he tests. That's why it's important to ensure that you're testing the correct points and that you understand the context of what you're measuring. If you find an open circuit, you need to consider the entire setup and see if the issue is within the grounding sheet or if it's something else in the environment. Most measurement devices, especially multimeters, do come with user manuals that provide guidance on how to properly use them, including how to measure continuity, resistance, and other parameters. They typically offer step-by-step instructions and diagrams to help you identify the correct points to test. However, in some cases, you might need to do a bit of experimentation, especially if you're dealing with something unique or specific setup like grounding sheets. But generally, you'll get a good starting point from the manual, and with a bit of practice, you'll become more comfortable with it. And of course, if you ever have any questions, you can always reach out for more guidance. Of course, for budget-friendly multimeters, some good options include one Asher AI digital multimeter. This one is often available for around $10 to $20 and provides basic functions like measuring voltage, carrying resistance. Two Gardner Bender digital multimeter, usually priced around $20 to $30. That's a reliable option for general purpose use. Three Innova 3226 digital multimeter. This one is also quite affordable, generally around $20 to $30, and offers a good balance of features for beginners. These options are great for basic testing and will serve you well without breaking the bank. If you need more details or want specific recommendations, just let me know. Measuring the resistance of a grounding rod typically requires a bit more specialized setup than just using a standard multimeter. Usually it's done using a ground resistance tester, which can perform a 4-point measurement method. Here's the general process. One, a 3-point or 4-point method usually drive additional electrodes into the ground at known distances from the grounding rod. Then you measure the voltage and current between these electrodes to calculate the resistance. Direct measurement, to get an accurate reading, you generally need to measure the resistance directly between the rod and the earth. This involves placing one electrode near the rod and another at a known distance away, and then measuring the potential difference in the current flow. Three, using a ground resistance tester. These specialized devices will often send a known current through the ground and measure the resulting voltage, giving you a direct reading of the resistance. So while it's possible to get a rough idea from inside the house, the most accurate measurements usually require that direct testing with the proper electrodes placed in the ground. It's definitely a bit more involved than a simple continuity test.